I realized this was like right after lunch, so hopefully no one falls asleep. But what we're going to be talking about is using SaltStack to provision and configure infrastructure on Azure. My name is Jason. I'm an open source engineer at Microsoft. I know, open source at Microsoft. They actually pay me to contribute to GitHub repos. And I'm here on stage here with Ryan.
Hey everybody, I'm Ryan. Oh, I gotta turn this on, huh? Hello? Oh, there it goes. Hello. Hey everybody, I'm Ryan. I head up DevOps over at LogDNA, and of course use SaltStack to provision our machines on Azure. So, all you.
All right, so one of the cool things about my job at Microsoft is that we get the opportunity to just work with any partner and just help them catalyze their business and help unblock their development on Microsoft platforms. So LogDNA, our two companies, LogDNA and Microsoft, have had a very long relationship, and the most recent collaboration point is where we actually work together to migrate their infrastructure to Azure. And since they were using Salt, we actually contributed to Salt Cloud to make sure it works with Azure. And so that's what we're going to talk about today. So we're going to get started with kind of LogDNA's journey to Salt, and then we're going to kind of see this in action. So one of the critical workloads of LogDNA is actually an ElasticSearch cluster. So what we'll see is actually deploying and provisioning an ElasticSearch cluster on Azure and configuring it all using SaltStack. So it's maybe like a 40-60 split, 40% slides and 60% demos, so like terminals and code. And at the end, we'll leave a bit of time for questions and comments and concerns. So take it off from here.
Sounds good. Thanks, Jason. So just wanted to give you a quick background about what LogDNA is. We are a cloud logging management platform with a focus on speed and scalability. So that's kind of who we are. We went through Y Combinator in winter of 2015. That's a startup accelerator in the Bay Area. And later on, actually pivoted into logging when we realized that our internal logging tool was actually pretty awesome. And we're kind of here now. We actually teamed up with Microsoft at one point when we were writing our Linux agent. They reached out and said, hey, you want a Windows agent? And we said, yes, please. And they did it free of charge. And when we launched, we actually supported Windows and Linux for our agents, which was really great. Later on, we worked with Microsoft again, as Jason alluded to bring a native Azure Salt Cloud integration. There, I said it. And that was actually really useful because now we could spin up VMs in Azure using the new Azure portal at the time, which is really great. One really great thing about since then is that now that we've scaled up and have a bunch of customers, we actually have some local customers here. I'm not sure if any of you know Podium or Deseret Book. Either of you guys here? No, okay. I saw Deseret Book earlier. So that's really cool. So before we take a deep dive into SaltStack and Azure, I just wanted to give you a quick preview of what SaltStack kind of looks like in the LogDNA web interface. So these states probably look familiar. There's nice colors that sort of correspond to the ones you see in the terminal for the state output. On the left here, you'll see a little label called SaltStack. This represents a view. This is just like a saved search in your logs, a little query. And on the right, these happen to be the query for salt states that have come back. And you can see success, failure, change, all that fun stuff, and how long everything took. So we'll be using this later on in the demo to verify that everything did indeed go as planned. So we've heard about infrastructure being complicated and how SaltStack makes it better, but it really helps illustrate the point when I give you a concrete example of where we started from and where we are now. And so originally when I joined, we were on a team of total 3 engineers, and we were spinning up VMs using a cloud portal. We would click through each one and configure the machines and firewalls and SSH access and all that fun stuff. And then we go in and SSH and run bash commands that we shared via a shared notepad. And that wasn't the best, I'll be honest. It worked okay for a few machines. And when we started really ramping up and scaling machines, that just did not scale well. How many of you here have used bash scripts before moving to Salt? Cool, awesome. So not alone here. So this was not so great when we needed to scale quickly. And so we found SaltStack. So now our complicated bootstrapping kind of infrastructure rituals that we were performing earlier are now awesome little nice, neat YAML configuration files. And so that was a huge improvement. On top of that, we were able to use Azure resource templates, which Jason will talk about later, to spin up and bootstrap the Salt master. And then from there, use Salt Cloud to spin up any remaining minions and manage them through Salt. Once it was spun up, we would then go in and actually configure the machine without having to run any bash scripts ourselves. It's great. And at that point, our app would be up and running, and life was good. But more interestingly, I think, than just showing you bash to SaltStack is, why SaltStack from bash? Why not something else, right? There are other options out there. But Salt in particular stood out for a couple of reasons. It helps to understand that as a logging provider, we handle a lot of data. So we have terabytes and terabytes of data just kind of pouring into our system, and that can fluctuate, go up and down, those sorts of things. And we need to be able to handle that pretty well. And so having a fairly responsive, performant, and scalable deployment framework was really, really important to us. It also, as an added bonus, we really wanted to be able to spin up VMs directly through whatever deployment we were using, and Salt really fit the bill for that. But most importantly, when we were looking at kind of there are other things that do things like Terraform and Ansible and all of those things. What makes SaltStack special and different was that we found that the protocol used to communicate with the minions, 0MQ, was much faster than SSH. So we would get states returning in a couple seconds rather than waiting 30, 40, 50 seconds for something to come back for just a simple run. That was really great. Couple that with distributed masters, state enforcement, so if somebody decides to go in and manually modify a configuration file, corrects it straight back, and then also the open source and modular design of SaltStack from the very beginning made it really easy to just set up and use. And all of these points together contributed to kind of how we were able to convince the CTO to say, hey, we're going to go with SaltStack. So I just kind of want to mention that. And we've been happy with SaltStack ever since. So I'm going to kind of transition here from talking about the story of LogDNA to our actual demo. So I'm going to go into a terminal real quick and kind of show you how the repo that Jason and I worked on can be used to easily spun up an entire Elasticsearch cluster with the Salt master managing all the minions. So let me move over to a terminal here. So I'm going to run a script command here, and I'm going to do a create. And what this will do is this will go through and do the entire process, create all the things we need in Azure, all of the Salt Cloud commands we need to spin up the minions, all the commands to actually configure them, and then being able later on to go in and check all the results that were sent to LogDNA. So I'm going to execute this now because this takes a little bit of time, and then I'm going to hand it off to Jason to explain what this actually does. So here it goes, and we'll explain what resource groups are in a moment. Cool. All right, back to you, Jason.
Thank you. So exactly. So what we're going to see now is just deploying an Elasticsearch cluster onto Azure using SaltStack. So it's kind of a multi-step workflow, so let's walk through it kind of piece by piece. The first point that you'll see is the Azure resource template. So for those that are coming from the AWS world, it's very similar to a CloudFormation template in it that it's like a giant source file where you can define the topology of your infrastructure. So in our case, what we have here is a virtual network. Around that virtual network is a firewall or an NSG, network security group. So any communication into that VNet is by default deny all. But with the NSG, we're just opening up port 9200, which is the Elasticsearch port. And then also in the Azure resource template, we're also deploying a virtual machine. And the storage account is for the persistence of the OS disk. So the storage account is where we're going to persist the data disk and the OS disk of the VM. The next step in the series of deployments is that we'll then run bootstrap Salt on that particular VM, and it'll make it the Salt master. The next step is we'll run Salt Cloud to provision a couple more VMs within the same VNet. So we'll now have the Salt master. These two VMs will now become Salt minions. And then we apply a high state to make them an Elasticsearch master and Elasticsearch slave. Now, at a high level, this is kind of what we're going to do. So at the end of this demo, what you'll get is a VNet with 3 machines inside. And we'll kind of step by step walk through each and every single piece of this. So the first part is Microsoft Azure. So a quick poll. Do you guys have workloads on Azure? Sweet, sweet. All right, so just kind of cover some basics with Azure nomenclature. As you're going through the documentation, I think you'll repeatedly see this thing called ARM. It's not these two flailing things here, but it just stands for like Azure Resource Manager, and that's kind of the control plane that you interact with Azure. So anytime you provision machines or configure machines, you're interacting with the Azure Resource Manager. So the same way you interact with it through the CLI, through the portal, through the SDKs, it's all through the Azure Resource Manager. A thing to note, though, is a couple years ago, maybe 3 years ago, there was a complete migration. So there used to be this classic, so v1.0 Azure, and it's been migrated to Azure Resource Manager. So anytime you deploy anything through the portal nowadays, it's ARM. I just need to make this distinction just because it becomes important when we talk about Salt Cloud. Now, one way in which you can deploy resources on Azure is as I alluded to earlier, Azure Resource Manager templates. So these are really similar to AWS CloudFormation templates, Terraform scripts, but in it, there's source files, in our case, JSON, which defines the infrastructure, the topology of infrastructure you want to deploy. The neat thing about ARM templates is that it actually has built-in support for dependencies. So in our case, we want to deploy the VNet first. Once that's provisioned, then deploy the virtual machine and so on and so forth. So there's a dependency graph that gets built in. When you're getting started with ARM templates, a quick and pretty damn good resource is the Quick Start template. So if you go to github.com, Azure/Azure Quick Start templates, you'll see hundreds and hundreds of all these templates, ranging from simple templates that deploy a VM, like a Ubuntu VM on Azure, or more complicated ones that deploy like a Kubernetes cluster or a blockchain consortium. Another neat tool is also ArmViz, which I'll show in a second. So let me kind of break out of this and show you the magic behind the script that Ryan just ran.
It's next thing over. There it is.
All right, do you guys see that? Cool. So this is the script that Ryan just ran. Just deploy salt.shell. It's kind of a giant script, but most of it is just argument parsing. So in the top part, it takes a bunch of arguments, but the magical pieces are really these two lines of code. So the first line, AZ is the Azure CLI. AZ group create. So here we're creating a resource group. So with Azure, there's this concept of a resource group. It's purely a logical organization of your resources. And it makes it super easy to organize. So if you had like a prod deployment and a test deployment, you can have a prod resource group and a test resource group. So anytime you want to delete everything in test, you can just delete the whole resource group, and it'll delete all the ancillary resources under that. And so everything in Azure has to be organized in a resource group. So you can think of it kind of like as a folder. And underneath that, we have AZ group deployment create. And this is where we run that actual ARM template. So in this case, we run a template file called Azure deploy with a bunch of the parameters that we build up here. So to take a look at the template file, you can kind of see it's just a giant JSON file. It starts with a couple parameters up top, generally configurable things that you can do. Like for instance, we ask if you want to prefix the VMs with a certain prefix, sizes or whatnot. All of this is completely configurable. Underneath this is kind of a variables category. You can think of this as like constants that you want to put, that you want to kind of share throughout your JSON file. And then the meat of it is the resources. So this is kind of where we define, hey, we want a storage account, a virtual network. And if I scroll a bit down more, the actual virtual machine. So with the virtual machine, I say a dependency. So hey, deploy that storage account first. Deploy that VNet first. Once those two things are deployed, then deploy this virtual machine. Underneath this is extensions. So Azure has this concept of extensions. They're generally ways in which you can quickly configure your machine. So if you wanted to install like antivirus, or run a startup script, you can do that through extensions. So as soon as the machine boots up, it'll run this particular startup script, which this is, to be honest, very janky to look at, but the command to execute is this concatenation of bash, the startup script, and then a bunch of parameters to execute it. And I do agree, it's like really janky to debug and to look at. But as you can see, that this is a giant JSON file, and sometimes it's pretty hard to debug giant JSON files. So one cool tool that I mentioned earlier is ArmViz. So you can actually load up this JSON file and kind of visually see what you're deploying. So you can kind of see at the center of all of this is the virtual machine. The storage accounts, everything that you saw in that graph earlier. Now to dive into that bash script, we have SaltStack install. So as soon as that virtual machine in Azure boots up, it's going to run this bash script. It takes in a couple parameters, but the first thing it does, it actually gets line 21, goes out into the internet and grabs Bootstrap Salt shell and it executes it. So this is a quick and dirty, easy way to configure Salt onto that particular virtual machine. So to go through the commands, -m means once this script executes, I want this to become the Salt master. -p, install a couple of other packages. So in here, I want python-pip. and then I want to install salt from the latest nitrogen branch. So you can actually tag it to whatever salt release that you want here. In our case, we just want the latest nitrogen. Underneath this is where we install a bunch more dependencies like GCC. I think important thing to note here is we get a requirements file. So this requirements file, I'm not going to kind of show it, but it just lists a bunch of Azure dependencies that we need for Salt Cloud. So Salt Cloud obviously uses the Azure SDK to communicate to Azure, and this is kind of where we install those dependencies. So it's going to grab the Azure SDK, Python Azure SDK, and put it on the machine. Cool. So to go back to the slides. Cool. That pretty much covers Azure, and that's probably the only thing you need to know about it, but just because it's all abstracted away with Salt Cloud. So Salt Cloud, for those that aren't are you guys familiar with Salt Cloud? All right, sweet. It's an abstraction of all these different cloud providers, so you don't need to deal with the nitty-gritty details of Azure, GCE, AWS, EC2. All you need to interact with is Salt Cloud, and it integrates fairly well with the rest of the Salt stack. A thing to note, though, is with Azure, we're so awesome that we actually have 2 drivers for Salt Cloud. The first one is aptly named Azure, and the second one is called Azure ARM. So do you remember when I mentioned there's like a v1.0 and a v2.0 called ARM? So the Azure driver for Salt Cloud refers to 1.0, so the classic mode of deploying stuff on Azure. Azure ARM driver refers to 2.0, or the current state. So if you're ever using Azure or Salt Cloud, please use the Azure ARM driver, as that's kind of like the current state, because classic is pretty much deprecated now. Also, a cool thing I found out while doing these slides is that not only can you provision virtual machines on these clouds, but it also supports VirtualBox. So you can actually deploy a virtual machine on your own dev box on top of talking to Azure and GCE and Amazon and so forth. So how do you configure Salt Cloud? Salt Cloud has this kind of hierarchical, inheritance structure of all these configurations. It starts off with kind of a cloud config. And these are where you put global settings for your Salt Cloud. In our case, we put things like minion configuration, things that are constant across all your cloud providers. Underneath that is cloud providers. So this is where if you had like a multi-cloud infrastructure, you would have an AWS config, an Azure config, or a GCE config. And so that's where you kind of find configurations for per cloud provider. And then underneath that is cloud profiles. And this is where you define VM instances and what you want them to look like. So to get away from these pictures and actually kind of see them in action, see them in real life, let me break this out and go back to GitHub. Let's go back to the same bash script that we're running. So remember, this is the bash script that we're executing on that VM when it starts up. So the first thing I want to show you is kind of this cloud providers.d. So this is the Azure configuration. So you'll notice that it's using Azure ARM, so the Azure ARM driver, and there's just a bunch of other configurations underneath it. So since Salt Cloud is actually provisioning machines on the cloud provider, it generally needs access or credentials to do so. And so with the Azure ARM driver, there's 2 ways in which you can authenticate. One way is you can just pass in like the usual username and password. So in my case, I could put like jason.poon@microsoft.com. And my password would be my Active Directory password. Obviously, that's kind of sketch, just because if this file ever gets compromised, that's my actual password. So my life at Microsoft would be completely screwed over. Like my email, that's my email, my Azure, my access to Azure and everything. So I don't really recommend that path. So the path that's recommended is to actually create what's known as a service principal. So with a service principal, you can think of it as kind of a service user. But in essence, you can scope it down to the provisions that you need. So in our case, since Salt Cloud is really, all that's doing is provisioning of virtual machines onto Azure, we can just scope down the credentials for that service principal service user to only be able to provision VMs. So it can't, I don't know, deploy like a Hadoop cluster or anything like that. It can only do VMs. So underneath this, then, is a cloud profile. So this is where you define specific VM information. In our case, we're using CentOS, the standard size on Azure that we want, and a bunch of other configurations like SSH, username, and password. fairly standard. And then underneath that, you'll see there's kind of an inherent structure. So this ES node, or ElasticSearch node, extends from Azure VM. And then we have an ES master that extends from the same thing. The difference here is that we're just setting different grain information. So for ES node, we're setting this ElasticSearch role. And for ES master, we're setting up this ElasticSearch master. And that becomes important when Ryan talks about kind of the salt states. And then this is kind of a cool bit. So with Salt Cloud, you can issue Salt Cloud commands generally to start up one VM. With a map file now, you can actually just configure it to deploy your entire cluster at once. So instead of having to run Salt Cloud for every single VM that you want, you can create a map file and then run Salt Cloud with that map file, so this -m flag. Takes in a map, so these are all the VMs that I want to deploy, and then the -p flag. So -p just means parallel. So it'll kick off all these deployments, so I'll get 2 VMs provisioned in Azure all at once. Cool. At this point, let me pass this back off to Ryan to talk about the rest of the Salt stack.
Awesome. Thank you, Jason. All right. So you guys saw Salt Cloud. So you kind of know how Azure interacts with SaltStack. But I want to talk a little bit more in depth about what we actually do to set up our ElasticSearch cluster. So I know most of you guys probably know a lot about SaltStack, so I'll try and keep this brief. But just to go over the sort of basics here, we've got minions, which are effectively the client for SaltMaster. They then connect to SaltMaster, and you can now execute states, commands, formula files, whatever you need to configure that minion or minions through that particular means. What we usually use, at least here, to be able to configure them is what we call formula files. And each formula file contains a number of states, and these states tell these minions exactly how they want to be configured. So I'll give you an example. Many states actually use something like an execution module, so something like command.run, service.running, these sorts of things where you're making sure something's in an active state. You then kind of build your files with these states, and at that point you've kind of created a category of states called a formula. Once you're there, what we like to typically do is use grains, basically like a way to assign attributes to minions, like any arbitrary attribute, say like role ElasticSearch, for example, to be able to distinguish between minion types. At which point then in your top file, you can designate what exact formula files are run for which minion. So I'll show you an example. So here's the top file that we actually use in our example for the base environment. And we run common packages formula file and the logging formula file for star, wildcard, all minions that run high state or state.apply. So what this means is that this common packages file will have a set of states, like you can see here. In this case, it's just one, package.installed. And it installs git, tmux, and tree, which we all find to be very useful tools to have on a minion. Following that, there's a logging formula file, which I'll show you briefly once we break out of PowerPoint. And then below that, you can actually sort of match specific grain information to specific formula files. So in this case, the grain roles with the value of ElasticSearch. The ElasticSearch formula file is run, and similarly for ElasticSearch master, it runs the ElasticSearch master one. So pretty straightforward, but just wanted to make sure we're on the same page. And I'm going to break out and kind of show you what that looks like. So, all right, so scroll down here. So this is the top file we were talking about earlier that you saw here. In this case, because it's a bash script, we're literally just piping it into a file, so it's there when we actually run the commands at the bottom of the script. This was the particular formula file for common packages that we showed. And then here is the logging packages. So in this case, because I'm from LogDNA, I'm of course installing LogDNA agent. This allows me to collect logs and then view them in that web interface I showed you earlier. So this kind of does stuff, make sure it's running and all that fun stuff. It gets a little more interesting when we start configuring Elasticsearch. So how many of you are familiar with Elasticsearch? Oh man, awesome. Okay, so you guys know all about ElasticSearch.yaml and how to set up all of the master and kind of node communication. So in this case, we've just created an ElasticSearch.yaml file with dynamic information. So you can see here we're using grains to fill in FQDN information, what cluster that we set up in the profiles, machine profiles for Azure, and then we even have a discovery setting here to make sure that the masters and nodes know where to talk to. So it's very important. Here we install JDK 1.8 because Java Development Kit's required for Elasticsearch. And then in this case, we're using Elasticsearch 1.7, but you can use whatever version you like. We ensure it's running. We that file you saw is configured. And then more interestingly, we're actually going to use a plugin for Elasticsearch. How many of you have plugins in Elasticsearch? Got one? These are actually pretty useful. I'd recommend checking them out if you get the chance. They can do a number of different things. In this case, we use something called KOPF. KOPF is a nice little kind of command and control plugin where you can visualize what nodes joined your cluster, what indices you have, your sharding situation, all that stuff. So that's all in there. We're going to install it here so you can see exactly what happened in our spin-up. So further down here, we now do the same configuration, but for the node here. So same stuff minus the plugin. And then finally at the bottom, we're running our high state. So all of that work was just meant so we could run that one command, state.highstate. And so that goes through and runs all of those formula files in that order and has our minions bootstrapped, configured, and ready to go. And so at this point in time, we're going to check really quick to see whether our deployment actually finished. I don't know where we are in time. Oh, that's going to be tight. We'll see. Not quite done yet. Well, that's OK. We have a backup one, and it'll probably be done by the time I talk about that.
OK, so we've kind of tested this out, and it generally takes about 20-ish minutes.
It's been about 19.
To kick this off, and yeah, it's been about 19, so maybe we'll leave it. Maybe we'll finish.
That's OK. I'm just going to go into kind of what it would look like regardless, and then we can show you kind of what the end output is at the end. So normally what you do in this case, when you have a new particular kind of cluster spun up for KOPF, to access it on port 9200, we need to know the IP. That IP was dynamically assigned by Microsoft Azure. So we're going to go in here and refresh the page, look at the resource group, Salt Demo, which is the one I'm using. And this will contain, like we talked about earlier, all of those things that were visualized in ArmViz before. So you can see not only the stuff for Salt Master, but also for ES Master, for ES Node, all that fun stuff. So if I go in and I click on ES Master here, I can actually go and grab the IP address, which is pretty useful. So I'm going to grab it now. It may or may not be up yet, but we can refresh it later if it isn't. So I'm going to put the IP address in. The port we talked about that was open was 9200, the Elasticsearch port. And then we're going to access the plugin section, and specifically KOPF. So let's see if the magic takes. Oh, it takes. Awesome. So we have it here. What's up? Make it bigger? All right, we'll zoom in. I've got a request. So this is our Elasticsearch cluster with no indices, no data, no nothing. So we just started up from scratch, but it's all here. And if I flip back to the terminal, it finished in the time I was talking. Amazing. So this has all the information of what's spun up. I wouldn't worry about reading that too much. Just know it's succeeded here, so that's good. And we'll verify that in a couple of different ways. So I'm going to go to the nodes section of KOPF, so you can see not just the data nodes, but the master nodes as well. So you can see Salt Demo ES Master is up, what version of the JVM it's running, what version of Elasticsearch, and ES Node. Now, there's nothing on here right now. So that's not really terribly useful for demonstrating kind of push and pull, but the whole point is the cluster is up and running and ready to accept configuration, further configuration. And you can go in and modify this however you like. One thing I wanted to do as well is show you kind of what it looks like in LogDNA and how we use it to verify that everything was actually correctly configured. So if I go into this particular window here, this is the LogDNA interface you saw earlier. Do I need to blow this up? It's a little small. There we go. And this shows the state run results. And you can see the timestamp was about 3 minutes ago. So you can see that common packages installed and all the things that we talked about are all here. They all successfully changed something. And you can see how long it took. So it took a little bit of time to configure both, but they're all here now. So that's good. We can also verify even further that the interactions in our Elasticsearch cluster are what we expected. So this here is the Elasticsearch cluster log file on both machines. And you can see on ES Node here, it says it detected master right about in this line, and it added it into its known master list, and then joined the actual cluster. So pretty cool stuff. You can see it all in order and what happened, and your salt state results all in one place. So it was actually pretty awesome. And so you're left with a fully functional ES cluster. So that's the demo. I'm just going to recap real quick, and then I'm going to hand it back to Jason to give you some resources here. So summary, fun stuff. So I wanted to recap. We did quite a bit here. What's up?
Press that.
Flip from current slide. Thank you. So we went through quite a bit here. So we started out by running a single deployment command, just -o create, which just happened to be the way that we set up this script. And that went and took the ARM template, piped it to Azure, created a deployment, created a Salt Master VM, created all of the ancillary parts and things like virtual networks it needed, then bootstrapped the Salt Master with everything it needed, including all of the files it would need to then use Salt Cloud to spin up more VMs on Azure, and then finally configure each of the minions from the Elasticsearch cluster, and pipe the data to LogDNA, and be able to show all of this for this demo. So that's pretty cool. The actual thing powering the integration that you saw with the state runs is just a simple engine module that just kind of reads your states and pops them over so we can tell whether things were successful, not successful, that sort of thing. And so that's pretty much it. Now, I'm going to hand this back to Jason to talk about resources, and then we'll open up for questions.
So this is pretty much the last slide, so I'll leave you guys with a bunch of resources. If you're interested in kind of how our collaboration came about, Microsoft and LogDNA, you can check out that first link. That's actually a really hard link to copy, but you can check out that first link, and at that link, there's a bunch of other collaborations we've had. And if you've on Azure and you've hit any roadblocks and you say like Azure sucks because of X, Y, Z, I'd love to hear about, because that's what my team does, is help unblocks your road to Azure. Next thing is everything that you saw here today is completely available and open source on GitHub, up on Ryan's GitHub right there. LogDNA is at logdna.com. And then if you want another example, just because we ran through this kind of quickly, if you want another example, you can check out my repo, and that's kind of deploying an existing formula, so MySQL, onto Azure. So both of these repos, if you want to kind of exercise them yourself, if you go to the repo README, there's like a giant button, deploy to Azure. If you click that button, it's a UI-driven deployment, and you can just go click, 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 and with a click of a button, essentially, you can get an Elasticsearch cluster or a MySQL cluster. I think that one's just a MySQL machine up and running on Azure. So at this point, just kind of leave it open for questions, comments, and concerns, if you have any. Also, this is kind of a trick question, but do you guys like my shirt? But if you do, I have stickers for this shirt. So it can just come up right after if you want a sticker.
Question in the back?
If you have an existing SaltStack environment somewhere else besides the one you were sitting at, could you deploy everything without your ARM template and just use SaltStack for everything?
Yeah, you should be able to. I mean, we've been on a number of different hosting providers prior to Azure, and we did transition to Azure. And so that exact scenario happened, and we used our existing Salt master to originally start spinning up machines, and then we realized that it didn't make much sense to leave it there, and then finally ported it over. It was actually the order we did things in. So I would actually recommend that, because then you don't lose control over your other minions or have to have the split brain Salt master problem.
So the idea of the demo, like I said, ARM, Bash, then Salt.
Yeah, so
Just has an initial deployment.
yeah. So for, just to give context, if you didn't hear the question's like, if you don't have that initial ARM template, can you use, if you already have some other infrastructure, can you still use Salt Cloud? Absolutely. So like ARM was just kind of the entry point, but if you have some other means of deploying it, so like Terraform or CloudFormation or whatever cloud-specific thing of way of deploying that initial Salt master, then by all means. We just needed it there just to get the Salt master up and running. Oh, yeah. Just because those credentials are in that cloud configuration, so that Salt master could have been anywhere. The only thing it just needs to communicate.
You're right. I was just going to mention, you could just go into the salt install.sh and just copy paste the files you need, and you're done.
Yeah.
So, yeah. Other questions?
Can the Salt master running in Azure, can you use MSI for credentials?
So the question is, can the Salt master use an MSI for credentials? Sorry for having to repeat everything. I just need it recorded. An MSI like Microsoft software installer?
No, the managed security entity. It's an extension in Azure to basically assign a service principal directly to the VM, and then you can use get tokens from a local TCP connection.
I don't know enough about MSI to answer that. But that's a good question that I could probably follow up with you afterwards. Yeah.
We just generally use service principals ourselves, but that I understand that makes a lot of sense.
Yeah. That's a good question, though. Yeah. I'll figure it out. Yeah. If you come up and just leave me your contact information, I can follow it up with that.
Can you guys share the Git or link that PDF file for your notes? Okay.
Oh yeah, we can upload a PDF for sure. 100%, yeah. Actually, if you do it right after the presentation, I'll do that.
Oh, yes. I was supposed to, yeah. It was like a red bang email that we got, and we just kind of ignored it just because we were, yeah. Okay. Any other, yeah. I guess we'll leave it at that then.
You're welcome to come up, and we got stickers and stuff too if you guys want to talk.
Yeah,
about
please take these stickers because I don't want to take them home.
Yeah, they're all here.
All right, thanks guys. Have a good conference.